Dear students of B.Sc Part 1 and respected listener, a very good afternoon and welcome all of you to today's lecture. Dear students of B.Sc Part 1, I am going to deliver today a very special lecture on methods to write velocity of the reactions, which is selected from that is the B.Sc Part 1 Paper 3 Physical Chemistry. Chosen from that is the unit 5th age, that is the chemical kinetics. I will deliver today my lecture. How will you express, how will you write methods to write of velocity of the reaction in terms of that is the partial pressure. Dear students of B.Sc Part 1, once again I repeat, I bring to draw your kind immediate notice on our previous lecture. Yesterday we have delivered in the classroom here, in which we have expressed the velocity of reaction of reactant and product by various methods. Case 1 in terms of concentration, second 2 in terms of active mass, third one in terms of degree of dissociation. Method to write velocity of the reaction either for reactant or that is a product. Amazing result we got in terms of degree of dissociation for reactant and product to have the same value, dx by dt, degree of dissociation. The quantity, the fraction of total number of mole present in the solution participating reacting in chemical reactions to produce the products known as degree of dissociation, and is similar by that is of x. Except concentration, active mass, the value of velocity of the reactants for reactants and product to possess in terms of the same value dx by dt here. In our previous lecture, we have also explained about N/M reactions. We have calculated the value of velocity of the reaction, in which the directly number of moles for reactant and product multiplied. When we write in terms of velocity, we calculate the velocity of the reactions A and B, C and D. The total number of multiplied mole now will be written into the form of that is a fraction. Rest quantity, rest theory, rest postulate. Velocity of the reaction will be the same here, in which negative sign will be used here for reactants here and positive sign will be used here, and that is a product C here. Dear students of B.Sc Part 2, as reaction undergo, reaction move is forward direction, the concentration of the reactant decrease. I mean to say negative sign will be used here, and as during the progress of the reaction the concentration of products is increased, so that the positive sign will be used here. Now a very special, it is also possible to method the velocity of the reaction in terms of partial pressure. The question is raised here, what are the conditions, what are the reaction for such a reaction? Partial pressure will be used here. Next one in terms of partial pressure here. Dear students, in our previous lecture, if reactant and products are present in liquid and solid, then we will determine the value of velocity of the reaction in terms of concentration, in terms of active mass. In the case when all the reactants and products are present in the form of gaseous state in such a position, the concentration here, concentration of the gases are expressed in terms of partial pressure according to the kinetic theory of the gases of B.Sc Part 1 in gases. Fundamental concept phenomenon, partial pressure, we fill various types of the gases into a system, into a pot, then the force dropped in a particular internal area is known as that is a partial pressure here. So here I choose here an amazing reaction in which N2 is present gas, thrice H2 present gas to produce twice mole of NH3 is gas here. Hence N2 reactant negative sign, H2 reactant negative sign, because during the progress of the reaction concentration of N2 and H2 decrease. I mean to say here thrice mole is directly multiplied by writing here minus 1 upon 3. Thrice mole directly will be mentioned in terms of that is of fractions here. Similarly twice NH3, it will be written in the form of plus half dpNH3 upon dt. In our previous lecture we were mentioning dCN2 dCH2 dCNH3. Since we are using here gaseous state, reactant and product, in such a position partial pressure concentration will be placed here. Next one example, twice mole of SO2 which is present in gaseous state, 1 mole of O2 is present in that is of gaseous state, twice mole of sulfur trioxide is present in that is of gaseous state. So all reactant and product here are present in that is of gaseous state. So one can write Since SO2 reactant negative sign, O2 is reactant negative sign will be used here. Twice SO3 here, that is of plus SO3 is produced in terms of product. So concentration to increase, hence positive sign will be used here. Twice directly multiplies number of moles now will be written to express velocity of the reaction in terms of fraction. Minus half, 1 will be remain as such negative, and twice SO3 will be written, that is the plus half dsp ps partial pressure of SO3 or normally pressure of SO3 upon dt here directly multiplied 2 is now will be mentioned in terms of fraction plus half. After the completion of the definition of velocity of the reaction, rate of the reaction, dimension, unit, methods to write, now let us come next amazing topic. Let us proceed the chemical kinetics. Here I have mentioned here on the blackboard here, that is of types of the velocity of the reaction. I think, dear students of B.Sc Part 1, all types of the velocity of the reaction, there are so many kinds of the reaction and undergoing by means of ionic reaction, molecular reaction, catalyzed reaction, fast reaction. In such a position, it becomes essential. There are various nature of reactant and product, and on the behalf of various nature and product of reactant and product, the 4 types of the kinds of velocity of the reaction listed here. First one, initial velocity or rate. Second one, average velocity. Third one, instantaneous velocity. Fourth one, specific reaction velocity. Specific reaction velocity, or also known as that is of rate constant here. Students generally think all the rates are of the same here. When a graph, in order to explain once again, there are 4 types of the velocity of the reaction here. First one, initial rate. Second one, average velocity. Third one, that is of instantaneous velocity. Fourth one, that is of specific reaction velocity. Specific reaction velocity is also known as that is of rate constant here. In order to discuss, in order to know the basic conceptual of chemical kinetics, to explain, to learn by all means its mechanism, order of reaction, molecularity, it becomes essential. Its further kinds also. When a graph, in order to explain about these various kinds of the velocity, initial, average, instantaneous, specific reaction, rate constant, when a graph, I choose here on the blackboard here simple reaction in which 1 mole of A react 1 mole of B to produce 1 mole of C and 1 mole of D as product here. When a kinetic curve is plotted between the concentration and the timing here, the shape of the curve I have plotted is obtained on the graph by such a mean infinite point, that is of x. The kinetic curve is start, that is of maxima, and that is of point t is equal to 0. Curve will start, kinetic curve will start due to the low concentration, low 0% concentration of product here, and we will define by graphically all these various kinds of velocity of the reaction tomorrow. Till then, thank you very much. Thanks a lot.